Alright, deriving area of trapezoids formula. Here's our formula. It's written in blue. We have our trapezoid. Deriving means creating the more complicated formula from simpler formulas. Let's rehash what a trapezoid is. Got it open in Sketchpad. Notice there's at least one set of parallel lines, or at most, depending on the definition. We'll just take this concept here. I'm going to go ahead and make a trapezoid. We're going to split this apart into simpler trapezoids. And let me change this up a little bit. Alright, notice I've split the trapezoid up into two triangles. If I take the two triangles, let's come over to this program, and if I give some variables for this, I can derive the formula. Let's do that. Alright, so if I call, notice the base of the top triangle is the same as the base of the trapezoid, so I'm going to call that base 1. The same thing for the base of triangle 2. I'm going to call that base 2. Let me go and identify my different figures with little circles and 1s and 2s. Alright, now it comes down to finding your height. Notice the height of the top triangle, you have to take your base and extend it so that you can get your perpendicular height right here. That means that the area of triangle 1 is equal to the base, B1, times the height divided by 2. Now the area of triangle 2 is very similar. The height here is the perpendicular distance, and that's the same as the height on the other side, because this makes a rectangle with these two sides being parallel and this being 90 and this being 90. All right. That means that the area of triangle 2 is equal to the base 2 times the height divided by 2. All right, remember, this is set equal to the area of the trapezoid. Now I'm going to manipulate or change the form of this right side. When I do that, if I can create the area of the trapezoid formula, then I've derived it or proved it. Notice the height divided by 2 is in both terms, so I can factor that out. So notice I have height divided by 2, and this is multiplied by B1 plus B2. This is equal to the area of a trapezoid. Notice this formula comes from simpler formulas, in this case area of two triangles, because I broke apart the trapezoid into two triangles. I'm going to go back to Sketchpad and I'm going to split this apart differently. Instead of it being two triangles, I'm going to do three triangles. Let's do that. It doesn't really matter where this point is because I'm about to use variables anyways. So I'm going to select this, come back over here and paste it, and let's go ahead and mark this up and do it. But I'm going to shrink it down a little bit. Alright, three triangles. Let's go ahead and prove this one. This one looks tricky, but note the height of all three triangles is the same because these two lines are parallel and these make rectangles, the height, and this one has the height, which is all the same. Now the B1, I'll call that B1, is the distance of triangle. I'm going to call this triangle 2, this triangle 1, this triangle 3. Notice B1 is that distance. B2 is the total distance for the trapezoid, but I have it broken up into two pieces. So I'm going to call this A, and I'm going to call this C. So when I do my algebra, it won't be quite as bad. I'm going to zoom out a little bit to make this a little clearer. Alright, so I have some space to do my algebra. Now I just need to set up my equation. Triangle 1 plus the area of triangle 2 plus the area of triangle 3 is equal to the area of the trapezoid. Now I just need to find the area of each of the figures with the variables, simplify it, and see if I can get the area of a trapezoid. Area of triangle 1 is A times H divided by 2. The area of triangle 2 is B1 times H divided by 2. The area of triangle 3 is C times H divided by 2. Very quickly you will see that each of these terms share the H divided by 2. H divided by 2. So if I factor that out, I can have something closer to the area of a trapezoid. I have A plus B1 plus C left over when I factor that out. Now I need to pause for a second and say B2 is equal to A plus C. B2 is equal to A plus C. So if I take the A and the C and if I group them like this, then you will see that the A plus C is equal to B2. And that has the new area of a trapezoid formula all over again. Awesome. I'm going to do one more way in the video. Hopefully this will be pretty simple once you see me go through a few. Alright, instead of it being two triangles, we could do a couple rectangles. Now to do that, I've got to have the perpendicular distance here, which I'm going to get that point. Do the same thing over here. I'm going to hide these lines. I'm going to draw these deals here. And I'm going to go ahead and change this. Something like this. Yeah, just so it doesn't look exactly the same as the ones before. Alright, I'm going to do the same thing where I shrink this down, and let's go ahead and list out our variables and solve from here. If you can use one of the bases, you should. Note that the base here is the same. These are perpendicular as you saw me construct them. That means this is a rectangle because these two lines are perpendicular and these two angles are 90. That means that this is congruent to the opposite side. I labeled it B2, so these two are the same. Note that B1 is the total distance between there and there. So I need to give different variables for these. I'm just going to call them A and C. Note that A plus C plus B2 is equal to B1 by the way that I have it created. I'm going to call this triangle 1, this rectangle 2, and this triangle 3. If I add the area of triangle 1 plus the rectangle 2 plus the area of triangle 3, then it equals the area of the trapezoid. Now I just need to list out the different parts that I have. Area of triangle 1 is A times H divided by 2. Area of rectangle 2 is the height times the base 2. The area of triangle 3 is C times H divided by 2. I need to simplify this, manipulate it, and see if I can get the area of trapezoid formula. Now this part is where it gets a little tricky. Notice they all three have an H. That's easy to factor out. What's harder to factor out is this divide by 2. But I know that the area of trapezoid formula has the divide by 2, so I'm going to have to make it so that this part has a divide by 2. That means I need to multiply it by 2 and divide by 2, because 2 divided by 2 is 1. Notice I did not change the value of this. I just changed the form of it. By so doing, I now have a height divided by 2 in each of these. Height divided by 2. So I can factor out that height divided by 2, and I'm left with A plus B, H, not H, H over 2 times A plus B2, but there's two of them, plus C. Now, note B1 is equal to A plus C plus B2, so I can split apart this 2B2 into A plus B2 plus C. Note that's equal to B1 plus B2, all of it times H over 2. Now, this part right here is equal to B2 as you saw from above. So I can plug in B1. I can plug in B1 for that. Note I have the area of a trapezoid all over again. Now, the whole point of this is that we can derive the more complicated formula, the area of a trapezoid, from simpler formulas, in this case triangles and rectangles and possibly parallelograms. But for right now I just kept it down to triangles. 2 triangles, 3 triangles, a rectangle and 2 triangles. That's it.